Where everyone demands your trust, we prefer to give you ours. Aryabhatta Learning Forum Private Limited.
Hello students. Previously we've been discussing about SN1 mechanism, about nucleophilic substitution reactions, and today I will discussing about the basics of coordination compounds. First of all, what is coordination compound and what is the terms involved in the coordination compound? We can let me discussing now. Okay. First of all, coordination compounds. Coordination compounds. First of all, what compounds are known as coordination compounds? Okay, completely basic lesson. Okay, coordination compound definition. What is the coordination compounds? Previously, I am taking the compound. Here, that compound we can classify it into two ways based on our purpose. Two ways. The compounds, the first one is uh, coordination compound. And here double salts. That means here taking compound also mixed salt. Here also I am taking the compound is mixed salt. If the two are more than two salts are mixed with each other, it can produce one compound. That mixed salt will be classified into two ways. The first one is coordination compound and the double salt, and this is also formed by mixing of two salts, and this is also formed by mixing of two salts. Okay, what is the difference between the double salt and the coordination compounds? First of all, what is the double salt? Okay, double salt means here I am giving one of the example for the double salt. Here Morse salt. Morse salt means FeSO4 dot NH4 twice SO4 dot 6 H2O. This is the Morse salt. Okay, and this Morse salt in solid state it will be existent one compound. Okay, but in case of in aqueous medium, if it is involves in dissolves in aqueous medium, it will be dissociated. It will be dissociated means Fe plus ions are available, and ammonium ion NH4 plus ions are available, and SO4 minus 2 ions are available. This compound is also prepared by mixing of ferrous sulfate, ammonium sulfate. Okay, but in case of solid state it is one compound. But in case of aqueous medium, it will be dissociated into individual ions. The individual ions are observed. In that double salt. That means it can lose its nature. It can lose its identity when in aqueous medium. Okay? In aqueous medium, it can lose its identity. What is the identity? In case of solid, it is a one compound, fused compound. Okay, but in case of aqueous medium, it dissolves in water. What happens? The individual ions are observed. That means it can lose its identity. The identity means a solid state particle, one compound. It can lose. It will Fe plus 2. Ammonium ion and sulfate ions are observed. But in case coordination compound, here also I am giving one of the example. What is coordination compound? K4FeCN6. K4FeCN6, one of the example. Just you can observe, I am writing one of the particular groups in square bracket. Okay, here potassium out from the square bracket, but iron, cyanide, both are present inside the square bracket. Okay, inside the square bracket, that is the complex, that is the coordination compound. That means if it is dissolves in aqueous medium, what happened? Here we can observe K plus ion is observed, but FeCN6 whole 4 minus ion is observed. That means iron Fe plus 2 not observed, cyanide Cn minus is not observed. Okay, all individual ions are not observed in that case of coordination compound. This is called a coordination compound. That means it has identity. It cannot lose its identity. A partial ionization may be occurred, but not complete ionization. The complete individual ions are not observed. All individual ions are not observed. All individual ions are not observed. That means potassium is observed, but iron plus 2 or plus 3 is not observed. Here Cn minus is not observed. Okay, that means FeCN6 4 minus is one of the complex. This is the complex compound, I mean coordination compound. This is the difference between the mixed salts, I mean double salt and coordination compound. This is the definition of the coordination compound. Okay, the particularly definition of coordination compound means in solid state, in aqueous medium, it can exist its identity. Not completely, all individual ions are not observed. This compound is called a coordination compound. Are you understand? Clear? This is the double salt, this is the coordination compound, and the definition of coordination compound also, this is non-ionized part. Here also there is square bracket. We can indicate the coordination compound inside the square bracket. That means this part is not ionizable, non-ionizable part. Okay, this is the definition of coordination compound. Okay, next. Next, terms involved. What terms are they? The very important concept, the basic, and the coordination in coordination compound. Without the terminology, we cannot do anything in future classes. Okay, terms are very important. We know that what is the coordination number and what is the complexes PO. What is the homoleptic complexes? Thus the terms are there. All terms are very important for this topic. Okay. First of all, terms involved. What terms? What is the terminology involved in the coordination compound? First of all, already we can discussing about what is the coordination compound. What is the coordination compound? A non-ionizable part. Non-ionizable part means, I mean, we can represent in a square bracket. The individual ions are not observed. Okay. In that case, what terms? Here also I am taking one of the example. K4 FeCN6. Okay. Here what positions are observed? That means here potassium is there and iron is there, cyanide is there. Are you clear? Potassium, iron, cyanide. What are these concepts? The first of all, I am already discussing this part, very important, this part. Okay. This part is non-ionizable part. Non-ionizable part, this is the complex polyhydron. This is complex polyhydron. Okay, or complex sphere. It is also known as complex sphere. Okay, this part, non-ionizable part. And then ionizable part, K plus is available. That is known as counter ion. This is known as counter ion. This is counter ion, this is complex polyhydron total. Okay, in complex polyhydron again iron is there, cyanide is there, 6 is there. What is the iron? What is the cyanide? What is the 6? In that case, K4FeCN6. Okay, here this is the counter ion and this is the complex sphere. Okay, here iron. Iron is the central metal ion. Okay, this is the central metal ion. Maximum d block elements are exist in that position. Okay, maximum d block elements, because the d block elements, this is also another concept. Maximum d block elements can form the complexes. Why? Because the characteristics for the formation of a complexes having d block. The d block only have the maximum capability for the formation of complexes. That's why maximum d block elements. Okay, central metal ion. The central metal ion, it is act as a Lewis acid. Central metal ion act as a Lewis acid. Okay, why it is act as a Lewis acid? Actually, central metal ion, the definition is electron acceptor. The metal ion can readily accept, it has a vacant orbital for accepting of electrons. I mean, accepts the electron, accept the electrons. Electron accepting, it can accept the electron. That's why it is called a Lewis acid. That's why it is acting as a central metal ion. Okay, the central metal ion is readily accepting the electrons. Why? Because in that case also, cyanide. What is the cyanide? Cyanide is the ligand. It will be termed as ligand. What is ligand? What is the definition of ligand? Is very important in coordination chemistry. Ligand is have most significant role. Okay, what is ligand? Ligand means electron donor. Ligand is electron donor. Electron donors are called ligand. That means here we can understand, here a ligand is electron donor, central metal atom is a accepting of electrons. Here ligand acting as a Lewis base. Then you can easily understand what bond is existing between the metal and the ligand. This is the metal atom, okay, and this is the ligand atom. What bond is exist? Very important point. What bond is present? Coordinate covalent bond, day 2 bond. Ligand can donate the electron. That means ligand have compulsory having lone pair of electron or high electron density, negative charge or lone pair, existence of lone pair of electrons. Metal atom compulsory having vacant orbital for accepting of electrons. That's why the bond in between the metal and ligand is coordinate covalent bond. That's why it is also known as the coordination compounds. Okay, this is the iron, this is the cyanide. And what is the 6? Number is a 6. Here the example is a 6. I am giving another example, NiCO4. Here the number is 4. Okay, here the number is 6, here the number is 4. Here the Ni is the central metal ion, I am already told. Okay, CO is the ligand. Okay, and 4 or 6 is called, another term is the coordination number. Coordination number. Okay, that means the number of surrounded bonds. Actually, coordination number definition means the number of surrounded bonds. Number of surrounded bonds of central metal ion. I mean, here the central metal ion iron, this central metal ion surrounded by how many cyanide ions? 6. That means coordination number 6. Here nickel can surrounded by 4 carbon monoxide, I mean carbonyl, that is 4, coordination number 4. Here the coordination number 6, that is the surrounded bonds of central metal ion. If the central metal ion surrounded by 4, this is the coordination number 4, and 6, coordination number 6. Here coordination number is 6, here coordination number is 4. Okay, this is the coordination number. Based on this coordination number, we can decide the geometry, and this concept is related with the chemical bond. Okay, for example, coordination number is 2. Coordination number is 2. What happened? Here the coordination number 2 means metal have 2 bonds with 2 ligands. That geometry is linear. Okay, and if coordination number is 3, okay, next chemical bond related concept, trigonal planar. Okay, and if coordination number equal to 4, what is the coordination number 4? The coordination number 4, that means here the geometry is tetrahedral or square planar. There are two chances for coordination number 4, maybe tetrahedral or square planar. Okay, How we can decide the tetrahedral or square planar? There is a possibility tetrahedral and square planar based on hybridization. That is also another concept we can discussing later. Okay. The first of all, coordination number 4, tetrahedral. For tetrahedral, hybridization is sp3. For square planar, hybridization is dsp2. The different hybridization, different geometry is observed in case of coordination number 4. Okay. If coordination number 5, same thing. Coordination number 5. Here also trigonal planar. Okay. Trigonal planar. Sorry. Trigonal bipyramidal, not planar, bipyramidal. Trigonal bipyramidal. Okay. And coordination number 6. And here coordination number 6 is octahedral. Octahedral. In that case, coordination number 6, octahedral geometry, but the hybridization, there are two hybridizations are available, D2sp3 or sp3d2. Two hybridizations are available, but the geometry is octahedral in both the cases. Okay, this is the coordination terminology. What is coordination? The number of surrounded bonds of central metal atoms is called a coordination number. Based on the coordination number, we can discussing about the geometry of complex. In this chapter, the most important coordination numbers are 4 and 6. These two are very important in this topic. Okay, are you understand? Okay. Okay. Next one. Terminology is oxidation number. Oxidation number. Oxidation number is very important terminology. Why? Because this oxidation number, after finding of oxidation number, this terminology is used in further EIN calculation, effective atomic number calculation, and for finding of hybridization. In future classes, in future concepts, the oxidation number is very important. Okay, what is oxidation number? The oxidation number, another terminology, oxidation number is charge present on central metal ion. Charge present on central metal ion is called oxidation number. Charge present on central metal ion, that means K4FeCN6. K4FeCN6. In that case, K4FeCN6 charge. What is the charge of iron? Central metal ion. Charge present on central metal ion. Here the central metal ion is iron. What charge present on iron? Then we can find out. We know that the charge of potassium. Okay. Based on previous knowledge, potassium belongs to 1A group element. Potassium having charges plus 1 into 4. 4 potassiums are there. And again iron is X, we don't know. Why? Because D block elements having variable oxidation states. Iron exhibit plus 2, plus 3. Variable oxidation states are all exist. Then we don't know. Then we can find out on which oxidation state is forms this complex compound. Okay. And here the X and cyanide, actually cyanide Cn minus, this is called a cyanide. Okay, Cn minus, this is called a cyanide, and Cn minus, okay, that means charge is minus 1. How many cyanide ions are there? Minus 1 into 6, okay, equal to the total molecule is a neutral molecule. Total molecule is a neutral molecule, that means equal to 0. Okay. Here then we can find out the X. What is the X value? X value here, the 4 plus X minus 6 equal to 0. Then X value is plus 2. This is the oxidation number, and this is the charge present on the iron. That is the oxidation number. The very important terminology. Very important terminology. Okay. And I'm giving another example. FeCN6, another type, 3 minus. I'm giving one of the another example. FeCN6 3 minus. both are not equal, both are different. Okay, FeCN6 3 minus. In that case, how we can find out the oxidation number? In that case, iron is a central metal ion. Okay, and then the charge we don't know, then taken as X, and cyanide -1 into 6. Okay, and equal to, the molecule is not a neutral. Okay, it is a -3 charge is present, -3 equal to -3. Okay, and then here X equal to +3. That means here iron oxidation state is +3. This is another example. This is another example. That means complex may be present like neutral molecule or ionic molecule. Okay, whatever it is, we can calculate the oxidation number like this. Okay, now this is the terminology, one of the important terminology of coordination compounds. And the next one, another terminology is homoleptic and heteroleptic complexes. What is homoleptic complex and heteroleptic complex? Here I am giving two examples, then you can easily identify the definition, easily find out the definition of what is homoleptic, what is heteroleptic. Homoleptic, K4FeCN6, homoleptic, CONH3 6 times Cl3, this is also homoleptic, and another one is here CONH3 3 times Cl3, this is heteroleptic, these are homoleptic. Okay, what is the difference? What is homoleptic and what is heteroleptic? Homoleptic means same kind of ligand, same kind of ligand. Heteroleptic means different kind of ligands. Different kind of ligands. Okay, this is the homoleptic complex and heteroleptic complex. Are you understand? These terminologies are very, very important. Okay, in future the complex compounds based on these terminologies, these are completely repeatedly used in previous classes. Okay,
We got you loud and clear. The 2026 admissions are officially open. Tap the link in our bio to learn more. Aryabhatta Learning Forum Private Limited.